That's the top left-hand quadrant, which is females who are left-handed. And that equals 14.4. Okay? So what we're saying is the expected number of females who are left-handed out of 120 in a sample would be 14.4. We observed 12 in the sample. The expected is 14.4. So 12 minus 14.4 squared over 14.4. So that is going to be 2.4 squared over 14.4. And you can see that's about 4 or 5 on the numerator divided by 14.4. And that comes out to be 0.40. You calculate each one of those quadrants the same way. But to get the total calculated chi-square, we need to do this for each quadrant or each cell. So for example, the second one. Now this would be the percentage of males in the sample who are left-handed. So this is males left-handed. That's the quadrant we're in. And so now let's do the formula for that one. There were 24 that were observed out of the sample of 180. Now minus F sub E squared over F sub E. Now let's get the F sub E for the males who are left-handed. This is males left-handed. Okay? So that would be 12% times 180. And that equals 21.6. Okay? So back over here, we've got 24 minus 21.6 squared over 21.6. And if you calculate that all out, that comes to 0.2667. So that's where we get this number right here. Okay, then you would do the same for the other two quadrants. Now let me just set this one up, the 0.0545. Okay, for this one, okay, the formula for this one, remember, starts with 1 minus P. So it's going to be the 0.88. Excuse me, the F sub E for this one is 0.88, which is 1 minus P bar times 120. That's for the right-handed females. Okay, and that then comes out to be 105.6. Okay, so let's see, let me put this. Okay, the 0.045, sorry, 0.0545 we get by the observed, which is 108, minus 105.6 squared over 105.6. And that equals the 0.0545. And then I'll let you do the same thing for the 0.0364. Similar calculation. Now, then you add all 4 of these together. When you add them together, it equals the chi-square calculated is the sum of these 4 numbers. And that comes out to be 0.7576. Okay, you could see 0.4 plus about 0.3, and then these are very small, so 0.7576. The calculated value of chi-square is 0.7576. Now, let's say that alpha risk is 0.05 or 5%. So we're going to be working with 95% confidence. The degrees of freedom, remember, we said is R minus 1 times C minus 1. And we already said that was 1 degree of freedom. So let's go to page 796 in your books to the chi-square table. Remember, it's a two-sided distribution but a one-sided test. So we will go to the 0.05 column, which is the fourth from the right, 1 degree of freedom, which is the top row. So the chi-square critical value from the table on page 796 is 3.841. And remember, the calculated value was 0.7576. Now, the decision rule. If chi-square calculated is greater than chi-square critical value from the table, page 796, we reject the null hypothesis. Okay, so the calculated value of chi-square we said was 0.7576, and the critical value is 3.841. Now let's look at that on the distribution. Okay, chi-square looks like this. The critical value is 3.841. So here is 0.7576, which is chi-square calculated. Like other tests we've done, we know that if the calculated value is way out in the tail, we reject the null hypothesis. This, the calculated value, is sort of in the middle. It's not out in the tail. So we are not going to reject the null hypothesis. Okay? So not reject the null hypothesis. Therefore, we're saying that statistically, at 95% confidence, 5% alpha risk, the proportion of females who are left-handed equals the proportion of males that are left-handed. So what we're going to conclude is that the proportion of females who are left-handed is the same as the proportion of males that are left-handed. Okay, there's no statistical difference at 95% confidence or 5% risk. Okay, then for your homework for chapter 12.1, the problem, there's problem 12.3, that's confusing because it's in chapter 12.1 section. It's on page 468, and do the 3 parts of that. And then page 469, problem 12.8, but only part A. Thank you.